Here in front of me is a copy of the mathematics paper this afternoon. An interesting paper. I saw 20 multi-choice questions as usual, but this time they only had 4 extended response questions. So let me have a walk through to this paper 2. A function has a range of 6 to 12. Basically, the first one should have a range of 6 minus 3, that's a 3, and a 6 plus 3, that's 9. So that's not true. The other one is 6 minus 6, 0, and a 6 plus 6, that's 12. It's not true. This one should be 9 takes 3, that's 6, 9 plus 3, that's 12. So option C is correct. Question 2, all asymptotes of the graph y equals to 2 tangent pi x plus half. So let's have a look at the CAS calculator. I'm going to use the domain function 2 tangent 2 bracket, actually pi here, x plus 1/2, comma x. So you can see the x values cannot take n1. That means x cannot take any integers. So basically, if x not equal to, let's say, k, and the k belongs to integers, then the asymptotes would be x equals to k. The graph of f of x is shown below. Which one of the following option best describes the function y equals to f minus x plus 2? So basically, if you draw a reflection of this graph, like this bit will be here, and this bit will be, roughly the same. And this bit should be, let's say, here. Therefore, if you reflected the whole graph, kind of look like that. And then you shift that by, let's say, 2 units up. So 1 unit up, 2 units up. So it looks mostly like option B. Question 4, system of equations, no real solutions. So I'm going to use k divided by 2 equals to 3 divided by 2k plus 1. If these two ratios are equal to each other, that means the two lines have the same gradient. But meanwhile, I don't want any one of them to be the same as the last ratio because I just want different straight lines. So I'll do menu 371, but I only have one variable because the first condition I put there is k divided by 2 equals to 3 divided by 2k plus 1. The second one will be half k, but I'll just put not equal to k squared divided by 6 minus 2k. So you only have k equals to minus 2. Which of the following sets represent a function that has an inverse function? So we must have a 1-to-1 set. If you look at the first one, 1, 3, that's a point along. 2, 0, 2, 1. This means it's 1 to many. It's not 1-to-1. Minus 1, 3, 2, 2, and 3, 1. Let's have a look. Minus 1, 3, 2, 2, and 3, 1. Looks like if I draw a graph, yep, this graph is like 1-to-1 function. Then if you look at option C, minus 1, 3, 1, 3, different x value but the same y value, this is many-to-1. That's no good. And the last one, you also have 3, 3 here. That's a many-to-1 as well. So we can't take option D. The trapezium rule is used with two trapezium to estimate the area bounded by the graph of y equals to f of x, the x-axis, and the line x equals to 0 and x equals to 1. For which function will the trapezium rule estimate be larger than the exact area? So if you look at option A, let me quickly draw a graph. This is y equals to 3, and I suspect the graph looks like that. So if it's from, let's say, 0 to 1, you can see the graph is concave down. But when you draw, let's say, two trapeziums, straight line, straight line. So the details will be like that. So the trapeziums will be under, let's say, the curve. That's why the trapezium estimate would be less than, let's say, the actual area. So we can't take option A. Second one. This is a cubic function shifted by 1 unit up. So if I draw a graph like that, yep. And this is 1, this is 2. So basically, if you, let's say, draw two trapezia, then you can see the top edge is higher than the curve. So this is why you have the gap, and the trapezium areas will be larger than the exact areas. Option B. I don't think a CAS is necessary here. It's more of a conceptual understanding. Let's move on to look at question 7. The algorithm below, well, very simple pseudocode question. So firstly, we have n equals to 17 and k equals to 5. Let's check the while loop. Is 17 greater than 5? Yes. Then proceed with n minus k. 12 assigned to n. Now you print n. Let's put a column here, print. Yep, I can print the current n value 12. Then the current n value is 12, but the k value is still 5. So let's check. Is my current 12 greater than 5? Yeah. So I can now do, let's say, current n value minus 5. 12 minus 5, that's 7, assigned to n. And then I print n, which is 7. Third one, let's try 7 greater than 5. Yep, that's true. So I can do, let's say, 7 minus 5, 2 assigned to n. So my current print will be 2. Lastly, is 2 greater than 5? No. So we stop the algorithm, okay, and a while. And then the order of print will be 12, 7, 2. Option C. Question 8. We've got a confidence interval like 0.248 and a 0.552. So one thing I can figure out is, let's say, 0.248 plus 0.552 divided by 2. If you add them together, this will be 0.800 divided by 2. That is 0.4. The next thing is, how can I get, for example, the number of household? So one possible method is you get the, let's say, margin of error equals to 1.96, because that's a 95% confidence interval, multiplied by 0.4 times 0.6, p hat times 1 minus p hat divided by n. And then you get, let's say, 0.552 minus 0.4. And then you solve for the integer n value. So you can just do, let's say, solve button, 1.96 times square root 0.4 times 0.6 divided by n equals to 0.552 minus 0.4 comma n. And you get a 39.9. Well, honestly speaking, the closest answer is 40. Alternatively, you might want to try, for example, menu 665. So basically, the number of success, if hypothetically the n value is 40, 40% of 40 is 40 times 0.4, and the n value is 40, and I choose the C level 0.95, press OK and control enter. If I were using, let's say, 40 as a known n value, I'll be able to get a 0.248 and a 0.5518, which is rounded to 552. And that matches the given confidence interval. So I can also use that to ascertain option C is the intended answer. Question 9. M student walk to school. So we have walk. Transport, let's put it as T, other transport. So M student, N student, the total will be M plus N. The proportion of student walking to school will be M divided by the total. The proportion of the other category will be N divided by M plus N. And of the student walking, at least 30 minutes, less than 30 minutes. This is 1/5, 20%. The other category will be 4/5, 80%. And of the N student who use the different form of transport, 40%, that's 2 out of 5, take at least 30 minutes. And 3 out of 5 is the other category, you get less than 30. So the question wants us to find the probability, given that the time is greater than or equal to 30, walk to school. So basically you need the intersection between W and the time greater than or equal to 30 divided by the probability of time greater than or equal to 30. Now, your numerator is going to be this number times that. So you have m divided by 5 lots of m plus n. And then the denominator will be these two numbers multiplied together plus these two numbers multiplied together. So you have m divided by 5 lots of m plus n plus 2n divided by 5 lots of m plus n. So eventually when you combine these two numbers together, these two fractions, the 5m plus n will cancel each other and you get m divided by m plus 2n. Option A. Okay, consider f of g of x greater than 0. F of x, let's draw a diagram. 2x squared plus x minus 1. So you can see this is a nice quadratic, and if I change this value to 1, you can see it's cutting through minus 1 and the middle of 0 and 1. Eventually, we want to use f of g greater than 0. So you actually use 2g squared plus g minus 1 greater than 0, okay? Also just notice, this g, the range of g, if all x values are real numbers, we have minus 1 less than or equal to g less than or equal to 1. So basically, if you draw the graph, it indicates this is minus 1, this is half. You get a quadratic like that. No, not an absolute value, bear with me. Let me draw the graph again. Yep, something like that. And then you should be able to get, let's say, this axis g, this axis f of g. So you want to make sure you start from here up to 1. Okay, this is the feasible region. Alternatively, you might want to choose, let's say, these two inequalities to find a common part. 2g squared minus g minus 1, actually, plus g minus 1 greater than 0, and minus 1 less than or equal to g less than or equal to 1, comma g. So you'll be able to get, let's say, g between half, greater than half, but less than or equal to 1. So that's option C. A pretty creative inequality question combined with composite function. Then let's have a look at, let's say, question 11. The chart below shows the daily price of stock market share over a 30-day period. We'd like to find, let's say, the greatest average rate of change. So from day 3, this is day 3 to day 10. If I look at the average rate of change, that will be the gradient of this line segment. So this is option A. And option B is day 3 from here to day 17. So this is 15, 16, 17 to here. Comparatively speaking, if you use a ruler, you'll be able to draw this line segment. And you see line segment A has a greater steepness or larger angle than line segment B. But now let's also compare option C and D. From day 14, day 14 is here, to day 21. 21, I think, actually, this is not day 14. Day 14, this is 15, it should be here. And day 21 is here. Okay, this is option C. And Also, we have, let's say, day 14 to 28. 28, that's 25, 26, 27, 28. So here and here. So let's do, let's say, the line segment. Let me just adjust the things carefully. From your observation, you should be able to see these two lines are, roughly parallel to each other. The blue one is roughly parallel to C, but the purple line has the greatest, I suppose, the greatest rate of change, okay? Alternatively, you may also want to, let's say, calculate each gradient, but just be aware. What you're going to do is, this is a 334.8, and this one is 10,36.4. And the other one is, well, this one should be, let's say, 17,37.2. This point should be 14,35.0, and the last few points, you have a 2137, and this point should be, let's say, 27,39.4, I suppose. And then you do the calculation, etc., etc. For example, the first one, 6.4 minus 4.8, that would be 1.6 divided by, let's say, 7. That gives you 0.228, that's option A. And the second one is 7.2 minus 4.8, that should be, let's say, 2.4 divided by 17 minus 3, that's 14. So you can see this gradient is flatter because the gradient is smaller. And the third one is 2 divided by 7. Yep, actually, the last one would be, let's say, 9.4, 4.4, 9.4 minus 5 divided by, let's say, 13. Yep, that has the largest value. So option D is the correct answer. Not a challenging question, but you're going to quickly figure out the most suitable method to tackle this one. Okay, normal random variable x, it is known that x greater than 200 has a probability 0.325. So this is the right side, let's say, after 200. But why do I know 200 is on the right side of the mean value? Because this probability is less than 0.5. Also, if you have, let's say, 180 to 200, 180, well, maybe here, I don't know, roughly speaking. So you have a 0.589. Now, I'm going to find the z-score, and then we find, let's say, the unknown mu and a sigma. Okay. So Z1 is assigned to inverse norm. Well, remember, you have to use the left tail. So you're going to use, let's say, 1 minus 0.589 minus 0.325. So you get the first Z value, I suppose. The second Z value is just inverse norm, 1 minus 0.325. So you get a 0.45 something. Then you solve, for example, curly bracket, Z1 equals to 180 minus mean divided by standard deviation, and the Z2 is 200 minus A divided by B, comma AB. So you get a 195.01 and a 10.99. So therefore, option D would be, the closest answer. Question 13, well, you could guess, let's say, g of x. Suppose this is 1, this is minus 1, 2. You can have x plus 1 times x minus 1 times x minus 2. And f of x, you might guess this is a negative x. So you want to get the graph of g of f of x. So you can do, let's say, g2 is f2. You have x plus 1 times x minus 1 times x minus 2. And the next thing is draw minus x. Have a look here. Pretty similar, aren't they? Okay. So the next thing is you're gonna sketch, for example, f2 of f3 of x. Now you can see this purple graph. Looking at the options, looks like option C is the best answer, okay? So that's my comment, draw G of f on CAS. Question 14, the probability density function for a continuous random variable, you want to find the value of k. So the sum of the two areas should be 1 because it's a PDF. Then what you're going to do is shift plus from 0 to pi over 4, k times sine x dx plus shift plus pi over 4 to pi over 2, k times cosine of x dx equal to 1. And then you will be able to get, let's say, minus k root 2 minus 2 equals to 1. So k times 2 minus root 2 equals to 1. You push the minus sign in, you get a 1 over 2 minus root 2. And that is the correct answer, option B. Okay, graph of g of x goes through the point 1, 3. So you have various methods to tackle this one, but what I will do is, let me show you. I can create a very simple function. For example, let's suppose g of x is x minus 1 squared plus 3. So make 1, 3 the turning point, the most obvious feature on the graph. Then I'm going to sketch y equals to 1 minus g of 2x minus 3. So after the transformations involved, you'll be able to identify the turning point easily. So x minus 1 squared plus 3. Yep, the graph passed through the point here. Then you just do 1 minus f5. Notice this is your g f5, 2x minus 3. And have a look here. Previously, it was a minimum. And now it's a maximum. Okay? So you must have, let's say, 2 minus 2. Alternatively, you might want to identify a few, let's say, transformations like a dilation factor of, let's say, half from the y-axis, then translation by 3 over 2 units to the right, then reflection, and then translation by 1 unit up, etc. Okay, consider the function a times log e bx, a, b are non-zero. The derivative must have range 0 to infinity. We want to find the conditions on a, b. So basically, if you try, let's say, derivative or shift minus a times natural log of b times x, comma x. So now you have, let's say, a over x. Now let's discuss. Now, if your a value is greater than 0 and a b is greater than 0, the domain comes from b times x greater than 0, therefore x greater than 0. The derivative graph will look like this, just this branch. So the range is 0 to infinity. So this pair is true. But meanwhile, if you consider a less than 0, b less than 0, the domain from original function b times x greater than 0, when you divide both sides by a negative value, you will get x less than 0. So what you see is the graph will only have one branch. And for that case, if a less than 0, you will get, let's say, these two branches. But now if you only have x less than 0, you just have this branch. But the range is still 0 to infinity. So basically, we can have either both positive or both negative. Therefore, what we can say must be true should be option D, because we can't tell which case. Okay? So basically, that's question 16. Okay, let's move on and look at the next question. Let's have a look at the next few questions. Well, as you can see at this moment, I've got a little helping hand here. Well, that's because she doesn't want to sleep. That's why she has to work together with me. Let's have a question. Let's have a look at question 17. Hopefully you don't mind. So basically, if you see this integral statement, 1 to 2 f of x dx must be greater than 1 to 3 f of x dx. In our usual understanding, we would say the integral calculates the area, but eventually the area could have been a negative sign area. That's why if we double check option A, 1 to 2, let me just highlight this one with yellow. If I check with option A, this is the region, okay? So you can see this yellow chunk, it's a negative value. And then if I go for 1, 2, 3 using a green color, that'll be this big, okay? So obviously, the size of the green color is larger than the yellow color. But the problem is we have, let's say, a negative sign. That's why you can take it like a say. If this one is -1, this one is -2, -1 is greater than -2. That's why option A, I think, is a valid answer. And if you try the other options, you'll be able to see the same kind of logic behind, okay? So just be mindful, definite integral doesn't just give you, let's say, a positive sign area. It may well be a negatively signed area. Let's move on to have a look at question 18. Question 18, I actually recommend this approach. Let me just show you. Well, the question provides you 4 probability graphs, and we want to see 2 of them having the same mean value, okay? 2 of them having the same mean value. So basically, you can identify the x values and the y values or the probability values from the graph. Let's have a look. Menu, statistics, stat calculations, and one variable statistics. Let's choose a list 1. So I know the X list is always, let's say, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, etc. So curly bracket 1, 2, 3, 4, and 5. But now for the frequency list, I'll be using a curly bracket. For example, the first one is 0.1, comma, 0.4, 0.4, 0.1, and the last number must be 0. Notice there is a dot here representing a 0 probability, okay? And then press OK, Control Enter. Now you can see the expected value is represented by X bar, which is 2.5, okay? And then let's do the same thing, just copy down the input. Copy down the input, like if you look at the second graph, you have 0.1, 0.2, 0.3, 0.4. So I can just change the second list, 0.2, 0.3, 0.4, and the last number is still 0. Control Enter again. Let's have a look at the expected value. From the matrix, you can see now the expected value is 3. Let's just mark them down. So mu equals to 2.5, and this mu is 3, okay? And then let's repeat for the last 2. So I'll be going up. I'm still using the same list of X, okay? This one is called a probability mass function, okay? You learn that after 16 years. Point, let's say 4.5. And the second one is gonna be 0.25. And now you have, let's say, 0.15. And this one is 0.15. Control Enter. Yep. Let's have a look. I think the expected value is 2, okay? And finally, let's have a look at this one. Up, up. Oh, actually, you can see all of these dots have the same y value, which will be 0.2, 0.2, 0.2, 0.2, and a 0.2. Control Enter. So you'll be able to see, for example, very nice. This is mu equals to 3. So graph 2 and a graph 4, they will have the same mean value. That's why we choose option D. Okay. Alternatively, you can do the, let's say, the normal calculation, all the X values multiplied by its probability and sum them up. You can still do the same thing. Anyway, let's just move on. Question 19, let A be the point on the line y equals to x plus c, and B be the point on the curve y equals to log ex minus 1. A and B are placed such that the line segment AB has the minimum possible length, and this length is root 3. The value of C must be something. Well, because the question gave us, let's say, the 4 C values, we can just try each one and observe by inspection. So let me just check the calculator. Give me a second. Let me do some adjustment. Uh-oh, you dropped something. Okay, that is going to show you something different, okay? Control I, add graphs. So basically, it's yours. Basically, you have a log ex minus 1. So just type in natural log x minus 1, okay? And I don't think we need, let's say, a very large viewing window. Let's have a look. Drag it over there. Notice I would love to keep the length factor or scale factor to be 1. Now, if I go from, let's say, the first option, x plus square root of 2 minus 2. So you can see like, well, the shortest distance is sort of like from here to here, okay? From this x-intercept to a perpendicular to this line. But, well, does that look like a square root of 2? Well, I suspect not, because it should be, let's say, something along this line. And then if you try, let's say, the other option, try the root 2, you can see it's further away. The distance must be larger than 1.4 or square root of 2. If you try, let's say, x plus 1, well, looks like you can see from here to here. Just look at the square. The diagonal of this square is root 2. So the distance is larger than root 2. But if you, let's say, use the last option, x, you see this one, this point? I'm going to point that out, okay? The segment, if I select this point and this point. So this is just square root of 2. So this is really a lovely question, and I believe the answer is dog, okay? So we just use, let's say, the graph inspection without doing any calculus. Of course, if you want to do some calculus, you can try to construct, let's say, a distance function and then try to use derivative equal to 0 whatsoever, okay? All right, last one, the question 20. Question 20, I'll be, let's say, using the CAS calculator a little bit. Uh-oh. You want Daddy to pick it up? Okay, right here. Here you go. The last question, question 20. Let me just take a closer look. We have two functions. F of x is a to the power x and g of x is a to the power 2x plus 2. We try to identify an option with the transformations not mapping f of x to g of x. So make sure you circle the not, the phrase. And then control I, f of x. Let's just assign this one to be a to the power of x, and the g of x is assigned to, let's say, a to the power 2x plus 2. Okay? Yeah, this one, you have two functions, one exponential and another exponential, okay? So basically, option A, dilation factor of half from the y-axis, that is f of 2 of x, and then translation by 1 unit in the negative direction of the x-axis, that is f2 bracket x plus 1. So I'm trying to see if f of 2 lots of x plus 1 equals to g of x. You can see the CAS calculator tells me that's true. Okay, so that's a successful mapping. Then I'm going to try the second one. Dilation factor of half from the y-axis and then dilation factor of a squared from the x-axis. So if I try a squared times f of 2x equals to g of x. Okay, see that's also true, okay? So that is actually giving us a squared times f of 2 of x. And the third one, dilation factor of a from the x-axis. Let's try a times f of something. And dilation factor 2x. And translation 1 unit. A times f of 2x minus 1. Okay? So you can use x minus 1 equals to g of x. Can you see that? A to the power 2x minus 1 equals to a to the power 2x plus 2, which is not generally true, okay? So option C will be unsuccessful. All right, I finished the 20 multi-choice questions with you, of course, with the help of this little helping hand. Aubrey, say bye-bye. Bye-bye. All right, I will see you in another video for the extended response questions. Hopefully you all did very well for this one, okay? Good luck for your future study. See you later.